Here's the next question, number 42. A three-phase transformer rated for 33 kV by 11 kV is connected in delta star as shown in the figure. The current transformers on low and high voltage sides have a ratio of 500 by 5. Find the currents I1 and I2 if the fault current is 300 amps as shown in the figure. Okay, we have our options given to us, I1 and I2 values. Now if you look at the figure here, we see that the transformer is connected in delta to star connection, delta to star connection shown over here. Now the current transformers are connected and they have a certain ratio of 500 to 5, and the fault current here is 300 amps. That's what's given to us. Now the fault lies on the C phase. If you notice, it lies on the C phase. So there is no fault in the A phase. Therefore, the current I2 will be 0. So it all depends here on the phases. Since we see that the fault has occurred on the C phase, there is no fault on A phase here, therefore I2 is 0. So that's our first part. Now to look at the second part, in order to find the value of I1, we will have to take the rating of the primary side and the rating of the secondary side into consideration. So you must remember that the kVA rating of both sides must be the same. They must be equal. So we are talking about kVA rating, not the voltage. So the kVA rating of the primary side equals the kVA rating of the secondary side. I'll write that down. The kVA rating of primary side equals the kVA rating of secondary side. Okay, let's note down the expressions here. According to the question, now the primary side is the side of delta connection and the secondary side is the side of the star connection. So here we have delta connection and here we have star connection. We have to keep that in mind as well. So the kVA rating of the primary side, we would now have root 3 into what is the voltage value. The voltage value is given as 33 kV in the question. So 33,000 into IL, that's the line current, is equal to, now the kVA rating of the secondary side, take a look at the star side here. We have the current as 300 amps, that's the fault current. And we also have the current transformer ratio given to us as 500 by 5. And note that it has been written, its low and high voltage sides are given as 500 by 5. So we have to keep that in mind too. This side we would have root 3 into, the voltage is 11 kV, so that's 11,000 into, now it's time for the current. The fault current is 300 times, take the ratio of the current transformer. Now the current transformer is said to be 500 by 5 for low to high. Now we are writing for the secondary side. So be careful, you have to write the ratio in the right order. So it's 5 by 500. Now when you solve this, you should get the value for the line current. Root 3 can cancel out and you can do a whole lot here. You should have the value of line current as 1 amp. Everything cancels out really. So IL equals to 1 ampere. Now we need the phase current because we are finding out IL from the primary side and that's the delta connection. Be very careful with the line and phase though, okay? So I phase equals 1 by root 3 times IL. IL is 1 amp, so root 3 times 1 ampere. So we have our value of I2, it's I1. I1 equals 1 by root 3 ampere. This is our final value. We have I1 equals 1 by root 3 and we have I2 equals 0. That matches option A. I1 is 1 by root 3, I2 is 0. Well, I hope this explanation has helped.